Welcome to page 2, the probability challenge. On this page, we'll be calculating probabilities and we'll be converting each probability from a fraction to a decimal to a percent. We'll be using the probability scale to make decisions about the likelihood of each event. At the low end, we have impossible with a 0 probability. And on the other extreme, we have a 1, a probability of 1, which means an event is certain. In the middle, we have an even chance or a 50-50 chance. And close to 0, it's highly unlikely. Close to the number 1, it's highly likely. Let's use our cube to calculate some challenging probabilities. Let's take a closer look at some problems. If you already have some notes in this section of the page, grab a blank sheet of paper and complete your work on that blank sheet of paper. We know as we take a look at our cube, we have 6 possible outcomes. In our pool of elements, we could roll on a single roll a 1, a 2, a 3, a 4, a 5, or a 6. Each outcome is equally likely. Let's try some problems. Write down problem number 1. What's the probability of rolling a 4 or a 5 on a single roll? Well, we know there are 6 possible outcomes, and if 4 is a success or a 5, that means 2 out of 6. Which reduces down to a 1/3 chance. You're going to convert that to a decimal and then to a percentage. But you can complete that on your own. We'll correct each of the problems at the end of the video. Now, what's the probability? Let's try another one. Of rolling a 1 or an even number? Well, we still have 6 possible outcomes. If we look at our pool of elements, 1 would be considered a success, and then any even number, like a 2, 4, or 6. We have a 4 out of 6 chance or a 2/3 chance reduced. You're going to convert that to a decimal and then convert that to a percent. Again, we'll correct these at the end of this video. Let's try another probability problem. Let's say you're a winner on a single roll if you roll a factor of 12. But we have to remember what factors are. Remember, 1 times 12 is a factor pair. 2 times 6, 3 times 4. All those numbers are factors of 12. Well, if we look at our pool of elements, 1 would be a success, so would a 2. A 3 would be a success. A 4 would be a success, and a 6 would be a success. Well, out of 6 possible outcomes, there are 5 successes. Convert that to a decimal and then to a percent. Let's try another one. You're a winner if you get not a 7. Out of 6 possible outcomes, let's see how many of them are not 7. We know 1 is not a 7, 2 is not a 7, 3, 4, 5, and 6. All of them are not 7s, and that would make them winners. It would be a 6 out of 6 chance. What is that as a decimal and then as a percent? And finally, one last problem. And for our last problem, you're a winner if you get a number less than 2. Well, out of 6 possible outcomes, there's only one number less than 2, and that's the number 1. So you have 1 success out of 6 possible outcomes. Divide and convert that to a decimal value, and then multiply by 100 and convert it to a percent. Pause the video right now and use your calculator to make these conversions. When you're ready, turn your video back on and check your work. Please pause your video right now. Let's check your work. When we take 2 divided by 6, or 1/3, we should get 0.333 ... repeating. When we convert that to a percentage, it's a 33.3 repeating percent. That's about here on the probability scale. For our next one, 2 divided by 3, or 4 divided by 6, gives you 0.666 ... repeating, which is about a 66.6 repeating percent chance, would put you right about here on the probability scale. Our next one, 5/6, well, that's 0.8333 ... repeating, which is a little bit over 83%. That puts you right about here on the probability scale. And of course, 6 divided by itself gives you 1. And when we convert that to a percent, it's 100% probability. We are certain that that event is going to happen. And lastly, 1/6, which has our weakest chance of all. 1 divided by 6 gives you 0.1666 repeating. And when you convert that to a percentage, you get a little over 16%, which puts us about here on the probability scale. This concludes the challenge for page 2.